Hi guys, this is our second lesson in Unit 1, which is the laws of exponents. Now let's take a look at the first law that we have in the laws of exponents. The first law talks about any number to the zero power. And in this situation, any number to the zero power is equal to 1. Let's take a look at the first example. The first example is 7 to the 0, which is equal to 1. And in the second example, we have x to the 0, which is also equal to 1. So if we have a number raised to the 0 power, or if we have a variable raised to the 0 power, both expressions are going to be equal to 1. Now let's take a look at the second law. In the second law, any number to the 1 power, or power equals to 1, it's going to be equals to itself. And an example is 7 to the 1 power equals to 7, and x to the 1 equals x. Third law is when we multiply two expressions. When we multiply, if the bases are the same, we keep the base and add the exponents. And an example is 7 to the 3rd power multiplied by 7 to the 9th power. In this case, what we need to do is to add 3 and 9 together and to keep the base. So the answer is going to be 7 to the 12th. Another example is when we have x to the 2nd multiplied by x to the 5th. We have the same base in both expressions, which is x and x. For this reason, we're going to keep the base and we're going to add the exponents. 2 plus 5 is equal to 7. Fourth law is when we have to divide an expression by another expression. Again, if the bases are the same, we need to keep the base, but this time we're going to have to subtract the exponents. And an example is 7 to the 9th power divided by 7 to the 3rd power. That means the answer is going to be 7 to the 6th power, because what we need to do here is to subtract the exponents. X to the 7th divided by x to the 4th. Again, we have the same base in both expressions, which means all we need to do is to subtract the exponents. 7 minus 4 equals to 3. The fifth law is when we have to raise a power to a power. We have one base. All we need to do is to multiply these exponents together. And an example is when we have 7 to the 2nd, and 7 to the 2nd is raised to the 5th power. And in this situation, the base is going to be 7 for the answer, and all we need to do is to multiply 2 and 5. And in this situation, the final answer is going to be 7 to the 10th. We have x to the 3rd raised to the 4th power, and in this situation, again, we're going to have to keep the base, which is x, and all we need to do is to multiply 3 times 4, which is 12. The sixth law, which is a product to a power. So what we need to do is to distribute the power. An example is when we have 7 times 3, both of these numbers multiply to the 2nd power. What we can do is we can distribute the power for each expression, in this case 7 to the 2nd, and then multiply by 3rd to the 2nd. Same thing when we have variables. If we have x times y times z to the 3rd power, what we can do is we can distribute the power for each variable. So we're going to end up with x to the 3rd, y to the 3rd, times z to the 3rd. The seventh law is when we have a negative power. We can change the negative power into a positive power by using the reciprocal of the base. And an example is 7 to the negative 2. In this case, negative 2 is the exponent. We can change that negative exponent into a positive exponent by using the reciprocal of the 7, which is going to be 1 over 7. So by writing down 1 over 7 to the second power, we change the negative exponents into a positive exponent, and the final answer is going to be 1 over 7 times 7, which is 49. Using variables, we have x to the negative 3. Negative 3 is a negative power. We can change that negative power into a positive power by using the reciprocal of the x, which is in this case 1 over x. Practice now using these examples. Stop the video, solve these problems, and then after that, play the video again to see if your answers are correct. A to the second times a to the third, a to the fifth, d to the fourth times d to the sixth is d to the 10th, r to the third times r to the third, we're adding exponents, is r to the 6th. Z to the 0 times z to the 2, that's z to the 0, which is also equals to 1. A to the 4th to the second power, that's a to the 8th. And a to the 5th divided by a to the 2nd equal a to the 3rd. And for the last problem, we have x to the negative 9. And again, we can change the negative exponent into a positive by using the reciprocal. Now let's talk about multiplying a monomial by a monomial. We have an example where we have 4x to the 3rd. This is the first monomial multiplied by a second monomial, which is negative 3x to the 2nd. When we multiply two monomials, we have to multiply the numbers first. And in this case, it's going to be 4 times negative 3, which is negative 12. And then multiply the variables. X to the 3rd times x to the 2nd is going to be x to the 5th, because in this situation, all we need to do is to add the exponents. Now we're going to talk about multiplying a monomial by a binomial. And in this case, we need to use the distributive property. The example that we have here is x times x plus 17. We know that x is the monomial in this case, and x plus 17 is the binomial. And by using the distributive property, x times x plus 17 is going to be equal to x times x, which is x to the 2nd, adding the exponents of 1 and 1 that we have here. And then after that, so the first step is to multiply x by the first term in the binomial. And then the next step is to multiply the monomial by the second term in the binomial, which is x times 17, in this case, which is going to be equal to 17x. So now we're going to multiply a binomial by a binomial. In this case, what we need to do is to use double distribution. And double distribution means that we have to use the distributive property twice. Let's take a look at the first example where we have x plus 3 times x plus 11. X plus 3 in this situation is going to be the first binomial, and x plus 11 is going to be the second binomial. So to do the double distribution, we need to start with x and multiply that x by the x in the second binomial, which is going to be equal to x squared in this case. So what we did is we multiply the first term of the first binomial by the first term in the second binomial. Next step is to multiply 3 by x, which is equal to 3x. So in this case, what we did is we multiplied the second term in the first binomial by the first term in the second binomial. third step is to multiply x by 11, and in this case it's going to be equal to 11x, which means what we did is we multiplied the first term in the first binomial by the second term in the second binomial. Let's erase that. Let's do it again. X times x, 3 times x, and then we have x times 11, which is 11x, and then the last step is 3 times 11, which is equal to 33. So the last step was to multiply the second term by the second term in the second binomial. Now, if we look at the answer, x squared plus 3x plus 11x plus 33, we notice that we have two like terms. 3x is one, and 11x is the second one. So in this case, all we need to do is to combine like terms. By combining these like terms together, we're going to end up with 3x plus 11x, which is equal to 14x, which make the final answer x squared plus 14x plus 33.